Hey everybody, Mr. Justin here with the Hernando County Public Library System, and thank you so much for joining us this week for our next science video. I hope you're all ready for some fun, because today we are going to have some fun with soda cans. So everyone might have like little soda cans lying around. For this experiment, I'm going to take a diet can, a regular can, and I have an empty can that we'll use for our second experiment today. But we also have this little tub filled with water, so you can do this in a sink filled with water, in a bathtub filled with water. If you have a bin like this, you can fill up with water, but we just need a nice big bin filled with water. And then this is where we're going to be using our two cans. These both need to still be closed and filled with the soda. And so I do have a can of Diet Coke, and I do have a can of regular Coke. And so what I'm going to go ahead and do is I'm going to go ahead and take one can at a time, drop it into our little bin, and we're going to see what happens when we put them into the little container of water. So should we start with the regular or the diet first? Let's start with the diet. So I'm going to put the Diet Coke right into the bin, and there we go. What happened with the Diet Coke when it was put into the water container? It looks like it kind of went down a little bit and then came back up, and it is currently floating. You can see there's a lot of space between the bottom and the can itself, so the can actually is floating in the water. So let's go ahead and take the next can, and this is just regular Coke, and we're going to go ahead and put this into the bin, and let's see what happens. And what happened? Did it float? Is it floating like the Diet Coke is? It did not. We'll put it that way. It kind of wants to go that way. There we go. It did not float. It is not floating. But let's look at both of these cans. They both are the same size. They're both the same material. They're both filled with liquid, both 12 ounces. Why does one float and the other does not? In this case, it is because of the one major difference between these two items is the sweetener used to sweeten the product. So here in this regular thin Coke, we have high fructose corn syrup, and we have aspartame and other artificial sweeteners here in the Diet Coke. And what's creating is, we used this magic word a few weeks ago in one of our other science videos, is we talked about density. And so when we talk about items floating, items that will float in water will have a lighter density than the water. Now if you sink, it's got a heavier density than the water, so it's going to sink down. And so we can determine that the sweetener used in this specific soda, whether it's the high fructose corn syrup or the aspartame and the other chemicals, is that the high fructose corn syrup, is more dense than the water, and the aspartame is less dense. And so since all those materials, chemicals, ingredients have different densities, that is why we have the sinking Coke can and the floating Diet Coke can. And what's also kind of fun is, depending on what angle you look at it, if you're at my angle, the cans don't look like their normal size. They look like they shrunk a little bit, so that's a little fun too. And so that is our floating and not floating soda can experiment right there. But I'm going to go ahead and push this to the side. Let's go ahead actually move this down, because we've got one other experiment. Like I said, you would need an empty can for this, any sort of aluminum can. This is a sparkling water can. Soda can would work too. And we need two different mugs. You can do similar mugs, similar size mugs. You can even do a bigger mug and a smaller mug. It doesn't really matter. You just need to make sure that the can will be able to fit inside of the can, inside the mug. And then what you would do is, we have one end. Let's put this to the side first. And what we're going to do is, we are actually going to breathe into the side of the mug like this. And look at that. You can see that we can actually raise the can to go up a little bit just using our breath. And what we're doing is, we are kind of changing the air pressure. It's using a little bit of Bernoulli principle right there. And what we're doing is, we are changing the air pressure, and the surface is going to increase. The pressure underneath the can does not, so it will kind of lift it up. And the harder you blow, the higher and faster the can is going to get. So I've got a little challenge we're going to do right now. So we're going to want to get your second mug. And I'm going to put the 2 mugs back to back. I'm going to put the first mug in here. And I am going to try to breathe into this and launch it and try to get it into the other mug. So let's see if I can get it. That's pretty close. Let's try it again. Oh, so close. Not yet. Okay, we can even move the mug a little bit if you think it needs to be moved. So what we're doing is we're changing the air pressure to launch the mug to try to hopefully get into the other one. It's so close. And you can change the distance of the mugs. You can change how hard you're blowing or how soft you're blowing to try to affect the flight of the can into the other mug. Oh, so close. I'll try a couple more times. That was close. I've only done this once before. So let's see if I can get second time today. Oh, that was so close. Maybe, oh, that was probably a little too strong. Maybe a wider mug will work better for me. But trust me, this can work. And I was filming this today not knowing if it was going to work or not to actually get it in the mug. You can practice and try. You can see how many times it takes you to actually get it into the mug. But again, what we're doing is we're blowing into this, creating like a pocket of air pressure, raising the air pressure around the can, causing it to launch up and jump out. And we're just using the other mug as kind of a landing place for us. So we're going to try a couple more times, see if we can get this. Close. They hit my face. Well, you get the idea. So like I said, you can try this at home. You just need 2 mugs and an empty can. See how many times you can do it before you can do it. Maybe you can do a lot better than I can and be a little faster than I can, because I'm going to be probably working on this all day. So thank you for joining us today as we talked about density, what floats, what doesn't float, and air pressure, all using different soda cans. So let's try one more time. And we'll see you next week. And I hope you all have a great one. Bye.